This video is going to be about hyperbolas and graphing hyperbolas. There are two types of hyperbolas. There are vertical and horizontal hyperbolas. A vertical hyperbola has the equation of y minus k divided by b, all squared, minus x minus h divided by a, all squared, equal to 1. And then the horizontal parabola, or hyperbola has the same equation except the x and y terms are switched in order, so you have the x minus h over a comes first, and the y minus k over b comes second. A vertical hyperbola, the actual shape of the hyperbola opens up like this, and down. Remember, the hyperbola opens in both directions. And then for a horizontal hyperbola, it opens to the left and to the right. So it's considered opening up here, opening down here, opening left, and opening right. And those arrows I just drew in are not actually parts of the graph. I'm just showing the opening. So when I refer to hyperbola that opens vertically, I'm referring to this one on top right here. And then when I refer to one that is opening horizontally, I'm talking about this one here. A couple of the important things in the equation are the h, the k, the a, and the b. H, k as a point will always be the center point of the hyperbola. And although we call it the center point, it's not actually a point on the hyperbola. And then a is what we call the horizontal dilation factor. And b is the vertical dilation. And these three things, the center point, horizontal dilation, and vertical dilation, are the three things that we're going to use to graph the hyperbola. So let's say we're given the equation y minus 3 divided by 5, all squared, minus x plus 2 divided by 4, all squared, equals 1. The first thing we want to do is identify the direction in which this hyperbola opens. Since the y term comes first, we know that this is going to be a vertical parabola, or hyperbola. Now what we want to do is identify the center point, the a, and the b. So for the center point, we're going to look at the k, which is right here, and the h, which is right here. Now remember, in the actual equation it says y minus k and x minus h. Since they're originally negative, we have to flip the sign when we write down what the center point is. So when I'm looking at this, the h term always comes first. So up here in the equation I have a plus 2, so I'm going to write down negative 2. And then over here I have minus 3, so I'm going to write down a positive 3. So my center point will be at negative 2, positive 3. The a value is always the value located underneath the x term, and so in this case a is 4. The b term is the one located underneath the y term, so in this case b is 5. Once we have this information, we have enough information in order to go ahead and graph this. So let me get a sheet of graph paper. Alright, so again, my center point is at negative 2, 3. So I'm going to go from the origin here. I'm going to go left 2, 1, 2. That's the negative 2 for the x. And then I'm going to go up 3, 1, 2, 3, which is the positive 3 for the y value. And so I end up with my center point right here at negative 2, 3. Now for the a term, I'm going to, that again is the horizontal scale factor. So from my center point, I'm going to go 4 units to the right, 1, 2, 3, 4, and I'm going to make a mark right there. Hang on one second. There we go. And then I'm going to go 4 units to the left, 1, 2, 3, 4. I'm going to make a mark right there. Alright. Now for B, it's 5, so from my center point, I'm going to go up 5 units, 1, 2, 3, 4, and 5. And then I'm going to go down 5 units, 1, 2, 3, 4, and 5. Now I'm going to draw in a reference box connecting those 4 points that we just made. Now the next step is to create some reference lines that are going to help us. You should know at this point that these are also called asymptotes. And so to draw these in, I'm going to start at my center point and then go out through the corners and extend it out off into the edges of the graph. Alright, so there are my reference lines. Now is when I actually start drawing in the actual hyperbola. So the first thing we need to do is remember we said this opens vertically, which means that our vertex of the hyperbola is going to be on the top of the box right here, and also there will be another vertex on the bottom of the box right here. Now what I'm going to do is I'm going to draw in the curves of the hyperbola, starting at the vertex and going along the edge of the line and then up along this asymptote. And then I start at the center point again, or the vertex again, and I go up towards the asymptote, and then I have to do the same thing on the bottom. Remember, this curve gets close to these asymptotes, but it shouldn't touch it. Like right there, I accidentally touched it, so I should erase that, and then try again. And make sure you have arrows on the ends of the hyperbolas. So this would be the graph for the hyperbola that we just had the equation for, which was y minus 3 divided by 5 all squared minus x plus 2 divided by 4 all squared equaled 1. This graph that we have right here is the graph of that hyperbola. Here's a practice problem that you could try on your own. I'm not going to post the result of this at this time. If you're in my class, you'll get to see it next class period. If you're watching this online, I wish you the best of luck at getting it correct. And if you need to check, there's a wonderful site that I will post a link to in the description where you can type it in and check your work. The last example that we just did was a vertical hyperbola. This one, since the x term comes first, will be a horizontal hyperbola. If we look for the center point, we can see that in this case our h is going to be a 3, because remember the sign has to change, so since it's minus 3 in the equation, it becomes a positive 3 in the center point. And in this case, the k, since it's plus 1 up there, will be a negative 1. So our center is going to be at 3, negative 1. Our a value, which is always with the x term, is in this case 2. And our b value, which is always with the y term, is in this case 4. So now we have our center point, our a, and our b, and we know that this one opens horizontally since the x term comes first. So let's go ahead and grab some graph paper and see if we can graph this one as well. So I can start by graphing my center point, which is at 3, negative 1, so that's going to be right here, over 3, down 1. And then my a value is at a 2, so my horizontal dilation is going to be 2. So I go 2 to the right, and I go 2 to the left from my center point. And then for the b value, I'm going to go up 4, because b is 4. And I'm also going to go down 4. So then I can draw in my reference box. And now I'm going to draw in those reference lines that we call asymptotes. And now that I have those drawn in, I can draw the actual graph, which again, we noticed that this one had the x term coming first in the equation, so we are going to have a horizontal asymptote, which means that our vertex is going to go on the left side and on the right side. Oops. And on the left and right sides of our box. And then again, we just draw on the curves. So we start at the center point, at the vertex, and go up towards the curve. Again, not touching those lines, and down towards the other asymptote. Down. And there we go. Those lines right there that I just drew in are actual hyperbola. Again, remember that the reference box and the asymptotes are not actually part of the graph. They're just reference points for us to draw the graph in. So this would be the example of a horizontal asymptote, or horizontal hyperbola, with the equation of x minus 3 over 2 all squared minus y plus 1 over 4 all squared equals 1. So why don't you go ahead and try this practice problem and see if you can figure out the graph for this one.